Welcome back to the solutions manual. In this video, we will solve the problem 2-35 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So to solve this problem, first of all, we have to resolve these forces into their components. So for the F1 force, I have a component along the positive y-axis and I also have a component along the positive x-axis. For F2 force, I have a component in a positive x-axis and I also have a component in the negative y-axis. So let's label them. So the x component of F1 force is F1 sine 30 and the y component is F1 cos 30. Similarly, the x component of F2 force is F2 cos 45 degrees and the y component is F2 sine 45 degrees. So far we have resolved these forces into their components. Now we have to find the components of the resultant force. So for the x component of the resultant force, let's call this Frx. So Frx is equals to sum of the forces in x direction, like along the x-axis. Since forces are the vectors, so I am considering this direction as positive. So we have F1 sine 30 plus F2 cos 45 degrees so Frx is equals to F1 is 400 newtons, so 400 into sine 30 plus F2 is 250, so 250 into cos 45 degrees. So upon simplification, Frx comes out to be 376.78 newtons. So this is Frx. Now we have to find the Fry, the y component of the resultant force. So Fry is equals to sum of the forces along the y-axis. I am considering this direction as positive for the y-axis. So we have positive F1 cos 30 minus F2 sine 45 degrees so Fry is equals to F1 is 400, so 400 cos 30 minus F2 and F2 is 250, so 250 sine 45 degrees. So Fry comes out to be 169.63 newtons. So these are our x and the y components of the resultant force. Now for the magnitude of the resultant force, we can use the Pythagoras theorem. So it is square root of Frx square plus Fry square. So we have square root of Frx square and Frx is 376.78 newtons. So 376.78 square plus Fry square and FRY is 169.63 newtons. So 169.63 square. So the magnitude of the resultant force comes out to be 413.2 newtons. So this is our first answer. We also have to determine the direction of the resultant force. So for direction, if I draw the x and y axes, so this is the y-axis and this is the x-axis. So by using the head to tail rule of vector addition, this is frx, this is fry, and the resultant can be drawn from the tail of the first vector to the head of the last vector. Let's label them. So this right here is fry, this is frx, and this is the resultant force Fr. And since we have to measure the direction counterclockwise from the positive x-axis, so we actually have to find this angle, which is measured counterclockwise from the positive x-axis. Let's call this angle theta. So for theta, we can use the ratio of tan. So tan theta is equals to Fry over Frx. So we have tan theta is equals to Fry, which is 169.63 newtons, divided by Frx, which is 376.78 newtons. So theta is equals to tan inverse of 169.63 newtons divided by 376.78 newtons. So if you take the tan inverse of this value, then theta comes out to be 24.2 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the resolution of the forces into their components or in the direction of the resultant force, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.